And we are back for our PSET 3 solution video. So let's go ahead and look at the image below and identify some of the defects, state the dimensionality, some defects may exist or not. So vacancy, 0D, self-interstitial, 0D, point defects, 0D, 0D, 1D, grain boundary, 2D, void, 3D, Frankel pair, 0D, 0D. So Frankel Schottky pairs, those are anion, ionic crystals. We don't see those here. Let's look and see what else we've got. So vacancy. There's a vacancy. Got it. What about a self-interstitial? So a self-interstitial is a point where it should be right here. Here we go. So self-interstitial is done because that's at a point or a place where there should be its own self-interstitial, so self. Impurity interstitial. Where could that be? Right here. There we go. Substitutional. Here, here, here. And you see the lattice distortion as well. Excellent. Grain boundaries. I don't think this is large enough to see a grain boundary, so I don't think we can see grain boundary here. Excuse me. Edge dislocation, yes. I can see edge dislocation here. I could actually see, looks like another one here and here as well. So we see those. Voids, nah, I don't see those any of those either. So, excellent. All right. Write the Frankel and Schottky defect reactions for PB203. So let's do Schottky first. So null goes to vacancy of PB, vacancy PB, plus vacancy of O. So remember PB, what charge is that? So that charge is going to be 3 plus. So we go from 3 plus to 0. So 1, 2, 3. And then this is going to be O. So 2 minus to 0, 1, 2. There's going to be 3 of those, 2 of those. Excellent. We also have PB, PB, X goes to PB initial or interstitial. 1, 2, 3 plus vacancy of PB. Oops, excuse me. PB, 1, 2, 3. And there we go. What about O? O, O, X. We go O interstitial, 1, 2 plus vacancy oxygen. 2, 2. All right, we've got it. Enthalpy of formation for Schottky is 0.1. Frankel is 0.7, which will be the dominant. Lower enthalpy of formation, because we know that from our Arrhenius reactions. So, excellent. All right. 3 defect reactions. Actually, let me get this tool here. So, we need to incorporate this into this. So, we need NCl, 3 goes into PCl5. And then we'll just repeat this. Goes into my impurity here, goes into my host. Let's go down just a little bit more. Cl3 goes to PCl5. Fantastic. One must include an anion vacancy. So a vacancy in my anion will be Cl. So Cl minus 1, so to 0. So there's 1. So then I could also do, let's do plus. Let's go N replaces N where a P should be substitutional cation. So this is 5 plus, this goes to 3 plus. So 5 to 3, you go to minus 2. Put a 2 there. And then let's see what we got. So I'm charge balanced. I have my N. I have my, actually I need to put plus. I need to do Cl, Cl, and I need 3 of these because now I have 3 Cls. What about P? P, 2 Cls, 3 Cls, good, we're good to go. So we needed the anion vacancy, so we've got that one. Cation interstitial, so a cation interstitial, so I'm going to do N on an interstitial site, that's going to be plus 1, 2, 3. So I could just do plus a, actually, let's see what we want to do here. Options, options, options. So I could put a vacancy of P. Let's do that. Vacancy, let's do vacancy of P. So vacancy of P would be minus 1, 2, 3, 4, 5. So I can do, for example, I need to add, let's see what we got here. So I could do 5 here, I could do 3 here. Let's take a peek at those. So if we do this, now we need to put 5 here. We also need to put 3 here. So I think we're good on that side. So now actually we just need to put 15 Cl, Cl, and I think that we're good to go. We got it. Fantastic. And the last one, we need a, Did the cation interstitial. Now we need a substitutional cation, so we can just do NP like we did previously, that too, plus I can do, let's do, what can we do here? I want to make it just a little bit interesting, but maybe we don't have to be too interesting. We could just put that there. I could also put a little interstitial. Let's put another NI. Let's make things a little bit challenging for ourselves. So NI 1, 2, 3. So actually we can, let's balance with this. So we got 3 here, 2 here, so we can do 3, we can do 2. So that's again 5. How many P's do we have? We've got 3 P's plus, there we go. We got it. So it worked out. Plus 15 Cl X. Got it. This one is done. So now let's go over here. Let's delete this. So I need to do alpha 07 into Ta205. So alpha of 07 goes into Ta205. Alpha of 07 goes into Ta205, and then alpha 07 goes into Ta2. Now this is obviously a crazy example. So alpha is going to be equal to 14 plus. Again, ridiculous, but let's just, again, we can do the same procedure. So let's do first an anion vacancy. So vacancy and oxygen, 1, 2. So how are we going to deal with this one? So let's put plus an alpha where Ta should be. So Ta is 5 plus. So this is, I'm just going to do 9 plus. So I'm just going to put 9 plus here. So how can we deal with this guy? All right, let's see what we've got here. So actually we can put actually, because these are pluses as well, because we need a vacancy in the oxygen. So it's very similar to the problem that we had previously. So these are all pluses. So I need to go to put a vacancy in my tantalum, and that's going to be a minus 1, 2, 3, 4, 5. So how can we deal with this guy? This is where, actually, I could put a 2 in front of this, because that would make this 2, and then now I would have 19 plus, this 20 plus, so then I could do for my tantalum, minus that, I could have 5 times 4 would be 20, so we'd be good to go there. So I could try to do some of those balances. So I could have 2 alpha 07, and I could have, how many tantalum do I have? 2 tantalum here, 4 tantalum, so I have 6 tantalum, so I could go 3 here. So I can go plus, so I'm good there. How many oxygens do I have? I need 14 oxygens, and I need 15 here. Good, works. So see, same thing works. Anion vacancy, another has to have a cation interstitial. So a cation interstitial, alpha interstitial, again, that's another 9 plus, or actually 14 plus, excuse me. 14 plus. We can do something very similar. So plus, I'm going to add a vacancy in oxygen. So that's going to be 16. And then I still need vacancy in oxygen. Then let's do plus vacancy in tantalum, 1, 2, 3, 4, 5. So what we can do is I'm going to make this 3. So that'd be 6, 20. So I could do another 4 here. So what do we got? We've got 4 tantalum, so that needs to be, keep that there. I need 2 here. So that means I need here. Let's see, 4 tantalum. So I need 2, 025. Now let's see what else we've got here. So let's keep it on track. So 14 there, 3 oxygens are already below. So I need 7 oxygens. Actually, this works out fine. Plus 7 oxygen X, and we got it. Good to go. And I'm not going to do the last one because it's already done previously here, but you can get the picture. Now finally, draw the Burger circuit for A and B, what's present, and show your selection. So so I'm going to pick my tangent vector B out of the board. I'm going to start here. So start. I'm going to do 1, 2, 3. 1, 2, 3, 1, 2, 3, 1, 2, 3. So start to finish. That's my burgers vector. Start to finish. So that is tangent, perpendicular, burgers. That's an edge dislocation. I'm going to go over here as well. I'm going to pick it out of the board as my tangent vector. And I'm going to start here. This is my start. And I'm going to go right-hand rule circuit. So I'm going to go 1, 2, 3, 1, 2, 3. I'm going to go 1, 2, 3. Actually, excuse me. I'm going to go. Actually, excuse me. I'm going to do tangent vector going out. So I'm going to start here. So I've went 1, 2, 3 steps, but I'm going to go 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and then I still need one more step here. So this is my start. This is my finish. Start to finish. Anti-parallel to burgers vector. That's a left-hand screw, and that's it. That is your problem set 3. So I'll see you all in the next video. Thanks. Bye.